Welcome to the Helix webinar series. Today's session is on best practices for service management. For those that did join a few weeks ago, we did run part 1. This is now part 2. So if you did miss that, don't worry. We will supply the recording in the thank you and the email that we send after with all the content. Today joining me is Nikhil Deshpande, our Principal Product Manager, Smeet Kulkarni, our Senior Technical Support Analyst, and Kashita Marath, our Product Developer. All three will be presenting and talking with you today. Hopefully you'll enjoy this session. Do remember that there is the Q&A section of Zoom that you can use. So during this presentation and demo, you can use the Q&A section of Zoom. Up until that point, you will remain muted, and then we will have roughly 20 to 30 minutes or so at the end where you can answer or ask live questions as well. So do stay interactive, use the Q&A section, not the chat of Zoom. You will find that at the bottom. So as we've got a lot to cover, I'm now going to hand over to the team to get us started. And yeah, over to you.
Thank you, Sam, and good morning and good afternoon to our participants from wherever you are joining this webinar. I'm Nikhil Deshpande, and I'm excited to be back presenting yet another webinar to our customers and partners. Over the past year or so, we have seen a lot of interest from our customers as well as partners in Helix Dashboards, which is now becoming the de facto dashboarding solution for the entire range of BMC Helix products. And as customers start adopting Helix Dashboards, we have seen from our interactions with customers that most customers do need help in terms of what are the best practices of developing dashboards, especially on the service management side. That's why we decided to create this webinar series where we share with you the best practices based on our experience and based on what we have learned from working with some of you and several other customers worldwide. Ultimately, the goal of these webinars is to help our customers get value out of Helix Dashboards. Broadly, we have seen that customers are looking for help in broadly 3 areas. First is how to design dashboards optimally for best performance and being able to maintain those dashboards in the long term. This part was already covered in the first part of this webinar series 2 weeks back. If you have missed that webinar, you'll certainly find a recording on BMC community, and we'll be happy to share a link of that page with you. The second one, the next 2 points on, can you go back to the previous page, please? Next, equally important is the art of writing efficient SQL queries. Now, performance, all of us know that whenever you're querying a relational database, there are certain do's and don'ts, certain best practices. We want to reiterate those practices, especially in the context of BMC service management products, ITSM, digital workplace, business workflows, and so on. So we'll share with you some of the best practices that we have learned over supporting our customers and developing dashboards for our customers. So which is why the art of writing efficient SQL queries, this is important. This is what we'll be covering in today's webinar. And the third part is about optimizing database performance. This is equally important. Now, writing efficient SQL queries is important for report developers or data analysts to be familiar with, but your admins, your database admins, or your ITSM admins, they will need to know certain things. What do they need to do to optimize the overall database performance? Whereas the second part is more for report developers or data analysts. Number 3, optimizing database performance is more relevant for your admins. So these 2 are what we are going to cover in this webinar. Next slide, please. So we covered the first webinar on 11th February. This is the second one today. Can you go to the next slide, please? If you have colleagues who are unable to join today, and if they're able to make it to the second one, we will be repeating today's webinar again on 27th February It's scheduled at 10 a.m. Eastern Standard Time or 7:30 p.m. India. Next slide, please. With that, I'm now going to hand over to Sumit, who will cover the first part of today's webinar. Over to you, Sumit.
Thank you, Nikhil. Welcome and very good day to all of you. I am Sumit Kulkarni, one of the senior technical support analysts here at BMC. I am with BMC over 6 years now, based out of India. So let's start with agenda for this webinar. So we will begin with streamline the query design to know how to plan and structure your query. Then we will drill down into the writing the optimal queries to cover the best practices to write the queries. The next, we will discuss troubleshooting the timeout queries in detail. And finally, we will wrap up with demo with use cases, followed by questions and answer session. So this is the process which we have discussed in the part 1 of this webinar series. So we have discussed the efficient process of dashboard development. So let me quickly recap the key points what we have discussed in the previous session. So the first is planning. This talks about defining the objective of the dashboard and choose the key metrics which is relevant to the use case. Then effective variable design. This is about designing the well-structured variable by following the best practices of variable design. Then next we have discussed about optimizing the dashboard efficiency. This is about how to use the dashboard features to reduce the initial load time of the dashboard and improve the overall dashboard performance. And finally, the test and iterate. This step is testing the data accuracy and validating the dashboard performance with admin and non-admin users. In this webinar, we are going to talk about writing the optimal queries, where we will be discussing the best practices of writing the optimized queries and different approaches to reduce the query execution time. So let's get started. So the first important step is streamlining the query design. This step is required as well-planned or well-structured query design set the foundation for efficient and reliable operations. So before we start writing the query, we need to have the clear idea of what data we need, where it is stored, and how it is related. So it is required to understand the structure and content of AR forms or schema. This helps in defining the criteria and logic of the query, such as filters, join conditions, aggregations, and the calculations. Then we need to focus on retrieving only the required data and the columns to keep the queries efficient and fast. Also, we need to focus on properly formatting the SQL queries as it enhances the readability and simplifies debugging. So this can be done by adding a meaningful alias for columns or tables, by using uppercase keywords, breaking the queries into multiple lines, and adding the comments to improve the structure and clarity. So it is always good to include the comments that clarifies the different section of the query and help others and yourself in understanding the query. Okay, I will now move on to the best practices of writing the optimal queries. So the first is avoid select star and apply the select distincts whenever it is required. So running the queries with select star retrieves all the information from the database table, including unnecessary data which can be time consuming. A better approach is to use the select statement with specified columns to fetch only the required information. Also, while select distinct is useful for removing the duplicate rows from the query result, it can have a significant impact on query performance. This is because the database has to process the entire result set to identify and eliminate the duplicates, which can slow down query execution. So it's important to use the select distinct only when it is required. The next approach is defining the appropriate filters and use the static values when applicable. So it is always recommended to defining appropriate filters and limit the data returned, as it improves the query performance by reducing the volume of records processed. Filters ensures the data is relevant and focused on the user's needs, such as by selecting the specific time period, group, or company. So also static values in where clause helps to optimize the query performance. So these fixed values simplifies the query logic and ensure the consistent result. So using these static values such as specific status or time ranges enhances the query speed and clarity. The next approach is use uh, small date ranges and default filter values in variable. So limiting the time range in variable helps to reduce the amount of data processed and improving the query performance. This is important for the dashboard that need to display the raw information having multiple columns in table visualizations. Also, setting the default filter values in a variable ensures consistent query results and reduce the need for users to manually input the filter values. So this improves the overall user experience. So default values also helps to prevent the errors or incorrect data filtering, providing more accurate result by default. The next part is use where instead of having for filters. So using where instead of having for filters improves the query performance by applying the conditions before the data is aggregated. The where clause filters the data at an earlier stage in the query execution. It reduces the number of rows processed. So this is beneficial when filtering the raw data rather than aggregated results. On the other hand, having is designed to filter the aggregated data after the grouping is performed, which can be less efficient. Therefore, it is recommended to use where whenever there is a need to filter the unaggregated data or raw data and optimize the query performance. The next approach is apply the appropriate filters in subqueries. So applying the appropriate filter in subqueries is crucial for improving the query performance. By filtering the data within the subquery can reduce the volume of information that needs to be passed to the main query. So this approach also ensures that the subquery retrieves only the necessary data before performing joins or further operations. In complex queries, effective filtering within the subqueries can prevent unnecessary data processing, and it also enhances the overall efficiency. The next part is join on primary keys and add the relevant condition in the join clauses as well. So joining on primary keys ensures that the relations between tables is clear and efficient, as primary keys uniquely identify the records. This approach minimizes the chance of incorrect joins and ensures that the data is accurately matched across the tables. So adding the relevant conditions in the join clause further refines the result and limiting the amount of data processed and improving the query performance. So by applying the filter directly in the join conditions, we can reduce the need of additional processing step, which speed up the execution. This practice optimizes both the correctness and efficiency of the queries. So especially when we are working with larger data sets like asset or CMDB. The next is minimizing the inner joins and avoid the correlated subqueries. So minimizing the inner joins helps to reduce the complexity of the queries and can significantly improve the performance by limiting the number of rows processed. Inner join often requires matching multiple tables on a specific column, which can lead to slower execution times. So avoiding correlated queries is essential because these subqueries reference outer query for each row. So instead of, we can use the joins to achieve the same result without need of correlated subqueries. And optimizing the query design by reducing the inner join and avoiding these correlated subqueries ensures the faster query performance and better resource utilizations. The next part is limit the size of result set. So as mentioned, it's important to only select the necessary columns rather than select star in the query. However, it is also important to limit the number of rows you are returning, not just the columns. So you can use the limit at the end of your query to reduce the number of rows returned. Adding the limit at the end of the query prevents you from unknowingly searching and returning thousands of rows of data when you just want a specific set. So this is all about the various best practices. With that, I will now hand it over to Kshitija, who will talk about troubleshooting the timeout queries. Over to you, Kshitija.
Hey, thanks, Sumit. Uh, Welcome to the part two of the webinar series, and myself, Kshitija Marathe. Um, so today I'm going to talk about troubleshooting timeout queries. So frequently we see whenever we are running the or testing the dashboard using non-admin users, particularly, we get face timeout issues, or we see unknown system error or on the screen, or we see timeout due to busy server. So how to tackle with these errors? So sometimes it happens with admin user as well, but usually non-admin users face these issues more than admin users. So as Sumit has already covered in detail that how to design the optimal queries. So based on that, let's progress further on troubleshooting part. So first of all, what you need, um, what all points you need to consider while troubleshooting timeout queries. So ensure variables which are designed, they have so you have practiced the recommended approaches whenever you have designed the variables for the dashboard. So as mentioned earlier, first of all, you need to know your data. So if we specifically look at IT service management use cases, then you need to know the metadata layer a bit, like what all are my enum type of fields, like status, priority. So usually these fields are not uh, values are going to be fixed, so you can go for the static type of variable there, instead of writing a query and fetching the data from the server. So if you know your data, then you can choose the variable type correctly and design it accordingly. Also, we need to ensure that uh, if you want to have a multi-select on variables, then you can switch on that all or null variable handling flag, wherein whenever you will select all in the variable value, the panels will have the GUID passed, and server will understand that uh, the particular where condition need to be removed whenever that uh, query is getting executed on server side, because you have selected all means the where condition uh, will be removed whenever it is getting executed at DB layer. And uh, because of having enabled uh, this flag enabled, you can reduce the execution time, definitely. So going further with a second point, which is ensure query optimization strategies, which are so you need to follow the strategies which we have already covered in part 1 and part 2, so that you will not face or there are less chances you will face these timeout issues. So you need to take care of whenever using distinct, you need to ensure that really the distinct keyword is required or not. Otherwise, don't use it unnecessary. Then instead of where condition, you are using having condition. So if really it is needed or not, that you need to um, take care and ensure. Then you need to use date filters so that the data will be filtered. And subquery part, I'll uh, discuss more whenever I'll talk about the actual use cases and um, how to tune the queries which has subqueries into it. And then limit part as well. So you need to limit your result set so that you can focus on what use case you are looking for. So you will not show unnecessary all the rows which are not required. So you need to have those filters. So sometimes default setting default filters in the dashboard also helps. Then third point which I want to cover is about breaking down the query to identify problematic areas. So um, whenever we are looking at timeout issues, then first what we do is we look at the query structure. Then if it is having distinct and it is needed or not, that's the first part. Then inside main query, if you have subqueries, let's say you have 2 or 3 subqueries into it, then look at if you can break down those subqueries. So for example, I have 2 subqueries into my main query. Then uh, 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 select that particular part of subquery and copy that and create one panel and check in how much time you're getting the output. Then copy second subquery as well and see similarly. So this way, you will be able to identify which is the problematic subquery and how I can uh, tune that subquery first. And after tuning subquery, you can uh, add that fix back into the main query, and then the things can start work for you. Then the fourth point which I want to cover is about adding missing indexes. So let's say you have ensured all the first 3 points which we have covered, and still you are facing the challenges and you are unable to solve the issue. Then this is the last step which you can go for. Like first of all, you need to look at how much time the query is taking, and then take API SQL logs and get the database query. And from that database query, you need to take particular DB query and um, run it directly on database. So in case of SaaS customers, yes, BMC will help you out running that on direct database. And then with the help of DBA, we can get the explain plan. And from the explain plan, we can identify if there are any missing indexes, and those can be added to fix the issue. And in case of on-prem customers, uh, I think all the environment control is with customer, and they can follow this practice, running it on direct database and comparing the output, and then have the execution plan. And with the help of DBA, they can figure out which are the indexes missing, and it can be added. So moving further, so how to write these optimal queries? So I'll just demo couple of use cases um, where we will look at the we'll compare the outputs between where the best practices are followed and where the best practices are not followed. You will see the difference in the timings. So here for demo purpose, I have the limited amount of data, but whenever it comes to the actual live customers data, then the timing difference you will see will be huge. But yes, we'll look at these use cases. Now let me. Yeah, so first use case I wanted to cover is about asset management. So usually these timeout issues we come across, timeout issues or in general performance issues uh, we get for asset CMDB, because uh, generally the amount of data is very huge, and um, asset or CMDB data is not kind of a data which is getting added on daily basis. So you cannot add this time picker date range in some cases, because it will not be appropriate. If we compare it with other incident or change or problem, we can add time range and filter out the data. But here in case of asset CMDB, you need to look for some other filter criterias and how to write the optimal query. So here I have the panel which is showing computer CI list. So I'll just go here, edit this, come here. Okay, so here if you look at, we have select distinct applied here. Then inside this main query, we have again subquery. This is the first subquery, which is uh, getting the data for computer system name and serial number. Then we have an inner join also in place here. And we have a second subquery here, which is trying to get the operating system version and operating system name. And this is the third subquery we have, which is um, getting the data related to IP address. Now here, if you look at, we have distinct in place. So we need to look at if really distinct is needed or not. Then in first subquery, I don't have any where condition added here. So uh, if we need to limit the amount of data set which is going to be resulted, then we need to look for the where condition. Then here we have inner joins. So instead of inner join, can we use left outer join? And that part also we need to check here. Then again, in these another two subqueries, we will look for the join criterias as well. So sometimes uh, in the join criteria also we can look for um, the data filtering part. So if while joining itself, if the data can be reduced, then your query performance will improve. So that part also we can look for. And at the end, limiting the overall result set. So if you look at the asset or CMDB, then we have a huge CI data there. So if we can reduce or limit the amount of data, then that also can be looked at. So um, looking at all these points, um, I have followed all these best practices in this another panel, which is a copy of this panel. Only I have changed, I've made some changes and followed best practices. So first of all, from the main query, I have removed distinct because distinct is not really required here because we have already CI name, which is distinct anyway. So there are no chances of duplicates here. So I'll avoid using distinct here. Then in the subquery, if you look at, I have added this where condition because I'm only interested in looking at the CIs which are in deployed status. So I will avoid or I'll filter all the other statuses like retired, cancelled, etc. That I have filtered with this where condition. And then another part is from which data set I want to fetch the data. And then primary capability. So these three things helps in reducing the result set. Then similarly, here in case of operating system, I have added this um, additional join criteria where I'm only pulling um, the data related to operating system from base relationship because I am not interested in all the types of CI. I'm only interested in operating system type. So that where condition I have added. And then in third, also I am interested here in getting IP endpoint related information, which is IP address. So I have added that criterion. And with that, I'm able to reduce the data at subquery layer only. Then moving to the next best practice, which I've followed here, is about have instead of inner join, I've used left outer join as it is more appropriate in this use case. And again, I have added this limit as well, so which is 50,000 as a best practice. And you will see if we compare the timing for this, then I'll go here. So this the original query was taking 3.57 seconds, and it reduced when I followed best practices to 1.42 seconds. So like this, we can follow best practices, and after doing changes, we can compare the result. Also, we can compare the same results with non-admin user as well. That's the part of testing and validation. This is the second example, which is on similar lines. It is related to computer system and printers. So we are showing both the type of CIs here. It's similar example, and you will see the end result. Earlier, it was taking 5.99 seconds, and after following the best practices, it is taking 1.44 seconds. And yes, in part one, we already covered about the variable part, right? So we can enable the all or null handling flag, the feature flag protected it is. And by enabling so, what we can do is we'll server will understand this GUID, okay, and whenever you will select all in that variable and pass that variable into your panel query, um, you will see in the inspect, if you look at that query, you will see in the where clause, this GUID is getting added. For example, here it will be like dataset ID in that GUID. So, and if on the server side, if that GUID is present, then server will understand and it will remove that where clause whenever the actual database layer query will be formed at the server. And uh, naturally, whenever there is a removal of this where condition, then your query execution will be faster as compared to the earlier. So this is a very good feature which we can go for optimizing the performance. And this is again status, which is uh, here you can use static values instead of writing a query. So I have used, uh, so I have added a custom type of variable here, and instead of getting the data from the query result, uh, this is hard coded because these values are going to remain constant. Um, and about the time range, if you look at, so as I mentioned already, for asset or CMDB, in most of the scenarios, this time range, you can't pass it because it's not a real daily basis transactional data, um, which is going to grow day by day. So you from this settings, you can switch it off basically. This time picker, you can hide it and it will not be there once you hide it. Then with that, I wanted to cover the second example, which is related to incident. Yeah, so here, if you look at again, I have this Petramco as a company set by default. So setting the variables with default values also helps improving the load time of the dashboard if it suits your need. And if we look at the query here, so as a part of the analysis, I just wanted to cover this part as well, that you have a header here, and if you switch on this header and search for timeout, here by default 2 minutes of timeout is set. So you can make it 600, which is 10 minutes. Why you need to do this? Just whenever you are doing analysis, you need to look at how much time your query is taking. So if it's about a timeout use case, then usually it takes time more than 2 minutes. And so if you want to measure exact time, then you need to increase this so that it will wait until 10 minutes before it throws timeout. So this header, you can switch it on and look for the actual timing. Then moving here to the incident management use case, which is again, so this is about fetching the incident details along with some associated knowledge articles, then associated assignment log, associated incident audit related data. So it has all the parts covered in the same query. So like this, if we have a huge amount of data which is being fetched, as incidents are, I mean, it's really a huge amount of data when it comes to um, the incident management module. So you need to follow the best practices to tune the query. So here, if you look at, we have, again, we have 3 subqueries here. So first subquery, which is using min function, which is trying to get the assigned date. So when the incident is in assigned state, at so it is trying to get that particular date time value. So this is first subquery. Then second subquery is about assignment log, where you're looking for assigned assignment type as assigned. And the last subquery, which is about the audit, you're trying to get the data from audit logs. And if you look at this fourth subquery, which is trying to get the associated knowledge articles. So here, if you look at, so this is the, these are the 4 subqueries we have. And if you look at the fixed part of the subquery, then here I have added this where condition. So earlier this date time range was not added. So that's the reason what was happening whenever help desk assignment log table, we were fetching the data from assignment log, and it is, as you know, assignment log is having a huge data again. So against one incident ID, we have multiple records in assignment log. So considering that, we need to have this criteria also added. Then if we are looking for particular submitter, or we want to um, filter out particular submitter, we can do that as per your need. And then particularly you can pass for particular assignment support company, as I have passed here as Petramco, because I'm interested only looking for the Petramco company data. So this, from where I have taken this, so usually what happens in main query, we tend to follow all these filter criterias, but we miss to follow the same filter criteria in subquery. And that's the reason what happens whenever subquery is trying to fetch the result, it takes more time. And further, all the subqueries will take the same huge amount of time, and your main query will suffer because of those subqueries. So best approach will be to add the same criteria which you have added in the main query, and then look for if your query is returning the same number of records or not, and then validate and test if it improves the performance as well. So based on your use case and based on your need, you need to make these decisions. But uh, in most of the cases, you can follow this, that from the main query, if you have any where condition, just try to add it in the subquery as well, if it is applicable, based on which table from which you are fetching the data in subquery. And you will see the result, the timing will be reduced whenever the query is getting executed. Yeah, and over here you can see again left outer join. I've followed, so I've removed the inner joins and followed left outer joins here. So, and you will see the difference in the result. And one more example which I wanted to cover, which is related to the, again, it is related to asset, but in this particular case, so if you look at the query here again, we are trying to pull the data from asset base element and the inventory storage. And to get this particular data, so inventory name, we have added these joins. So this particular join with base element. So base element is the primary table, and secondary table is inventory quality storage join. And again, to get the actual data, we need to have this inventory storage join also added and matched with inventory quality storage join. So what I found when I was looking into this query is this inventory name, I can directly also get it uh, without having this inventory quality storage join. So sometimes what happens, we while developing the query, we tend to add unnecessary joins, and that complicates the query unnecessary, even if it is not needed. So if you look at the fixed part here, so instead of this inventory quality storage join, I just removed this join and fetched this inventory name from inventory storage directly, because there is a way to join base element and inventory storage directly. So I found that way, and this is reducing one join for me. So definitely it is going to improve on the performance. So like this, we need to look at all the parts of the query, and wherever it is needed, we can look for tuning the query. Um, yeah, so with that, uh, we are coming to the end of this demo. So if I want to just summarize on what we have covered today, is about efficient process of dashboard development. So in part one as well, we covered about what all Helix dashboard features we can use, like panel as a data source, then calculated fields, then variable, how we can choose the variable type, etc. Uh, and today, what we have covered is all the process and best practices for dashboard development. And then how to design your query. So just now we covered using the 2-3 scenarios, how we can look for tuning the query performance. Then what are the ways to design optimal queries? We looked at that too. And lastly, how to troubleshoot timeout queries. That also we have covered so far. So with that, we have some reference points also I'm adding here. This will be shared with you, and you can use these references uh, in case required. So it is about using row limit configuration. So if you, some of you must be aware that on platform side, we have um, centralized configuration setting. We have JDBC row limit set. Then we have chunk size also set. So that JDBC row limit uh, setting you need to set at platform layer, and it will be applicable here in Helix dashboard. And then if you want to change that JDBC limit at Helix dashboard layer, then you can do that as well. But setting it up carefully, and so just ensure that so by default it is 10,000, but if you want to increase it, you can increase it to 50,000 as a row limit. So that's what we are recommending. If needed, you can increase it to 50,000. And I mean, if it's really required, then, and chunk size also you can define. Then if your data, for example, you have set it 50,000 and your data is, so you have a chunk size of 50,000, and if your data is increasing, so it's more than 50,000, let's say it's 1 lakh, then you will see two API calls if you look at the network logs to fetch the result entirely. So with the offset of 50,000, it will get the entire result set in 2 API calls. So just be mindful whenever setting this JDBC row limit as well as chunk size. Then to use calculated fields, then how to optimize query performance, whatever Sumit has covered, that part also you will get a reference points here. And we have added a list of some frequently asked questions as well related to Helix dashboard that you will get here. And in troubleshooting part, you can, so we are in the process of adding more troubleshooting part in the nearly future. But yes, there is already some questions or some errors, and resolution for those errors are captured in the troubleshooting part. And with that, let me thank you all, and I mean, we are good to start on Q&A. So I'll hand over to Sam to.
So we've got one question that's in the Q&A. The question was, is there any way to integrate dashboard views into PWAs? If yes, how can we do it? And can you please demo this on the same? And I'm just going to unmute everyone. So I don't know, Kashita, if that's a question that you want to answer.
I can take that.
Yeah.
Progressive web apps are different. So dashboards is based on Grafana. It's different from what we support in ITSM. So no, the answer is no. You cannot integrate these views in progressive web apps.
I'm not sure who asked that question because it's anonymous, but if you have any further questions on this, please reply back or come off mute. That's our only question at the moment. So if anyone does have any questions, feel free to come off mute, raise your hand, whatever is easiest.
Hi, Sam.
Hello. Hi.
Sam, so this was the question by me, and understand that we cannot integrate with PWS, but is there any also way to integrate with the Innovation Studio, or that is also a no?
Okay, now let me understand your question. It is possible to report out of using dashboards. You can connect to your ITSM data and develop reports. You can connect to any custom applications you have developed using Innovation Studio and build those reports. That is possible. But if your question is about the views, no, the views in dashboards, the visibility is limited to dashboards only. Dashboards, Innovation Studio, they're different technologies. So you can't see the views developed in dashboards in Innovation Studio.
Okay.
Hey,
Thank you.
Debabrat, I just want to understand your question again. So, are you looking at uh, having the starting point you need to launch the dashboard, particular dashboard from your Innovation Suite app, or
Yeah,
um,
let me put this way.
mm,
Let's say I have created a dashboard in the dashboard, and
mhm.
I want to show that views in one of the PWS. So when I launch the PWS, I want to show a, let's say, pie chart or something kind of a bar chart based on the reports. So can I integrate that dashboard instead of going to dashboard? I want to show that views inside of PWS or in the Innovation Studio.
So you can launch the particular dashboard. That is possible, but uh,
Are you looking for something like
yeah.
from within any of these applications? Do you want something like on the landing page, you want to display a report from
I mean, yeah,
dashboards?
kind of, yes, yes.
Okay. So that in theory, that may be possible, but we
Yeah.
haven't tested it yet. But it should be possible.
Yeah, embedding with,
Correct.
yeah.
Right. I mean, if you can have a demo on this someday, that would be really good.
Okay, we have taken that point. But yeah,
Thank
for now, the link is possible for sure. That is, we have tested.
Okay. Do we have any other questions? Don't be shy.
The quick one. Is there any
Morning.
way of good morning. Is there any way of putting config data from dashboards back to ITSM? Say, for example, report names, folder structure.
I didn't quite understand the question. Manuel, can you elaborate on this a bit?
Just say, for example, is there any way to get data from dashboards, like say the configuration of dashboards, like users and folder structure, back into ITSM that we can use to, say, for example, in DWP, if I want to share the list of folders that you want, that can be configured, right? Or like that's in dashboards. Is there a way to do that?
No, it's not. Remember, digital workplace is an end user facing application, and not
Yep.
all DWP users will have access to dashboards. Access to dashboards is limited to your ITSM paying users. In digital
Correct.
workplace, you will have read-only users or users whose entitlements are limited. So dashboards, it wouldn't be appropriate to show anything of dashboards in digital workplace.
Yep. So like the intention is like, say, because it's like how you said, right? User structure and stuff like that. If people want to have editor rights to a folder, we're creating a DWP request for that.
Okay.
So I was just wondering, instead of having static data, I was just wondering if we can get like dynamic data from dashboards of the file structure that's already there.
Not at the moment.
Okay. Is there any roadmap for that, or?
We may consider it depending on how widespread this need is.
Yep.
Okay. Do we have any more questions from anyone else?
Hello.
Hello.
Yeah. Yeah. So can we have any provision to bulk load the report permissions? Like let's say I'm having multiple users. Let's say 50 of users should have the access to one of the dashboard. Okay. So do we have any provision to upload that users data for the particular dashboard, or like right now we are doing it manually, like one by one we have to add those users and give access permissions. Do we have any provision for bulk loading it?
We don't support bulk loading, but we do support adding users to groups. Kshitija, what is it called? Is it called teams or groups?
Teams.
Teams. So you
Yeah.
can create a team, logical
Mhm.
teams, like similar to what you would create assigned groups in ITSM. And to these teams in dashboards, you can add those users. So every time a new user is added to a team, you don't have to manually grant them access.
But also in teams, like if I wanted to add 50 of users, that activity I have to do it manually, right? One by one I have to add into
That's
teams,
correct.
right?
That's
Okay.
correct.
Yeah. And also in our environment, like you, let's say I'm using dashboard for 10 to 15 minutes, and all of a sudden I'm active on the dashboard. Okay, but all of a sudden the connection goes out, and some error pop up like a fail to fetch. We checked with our network team as well, but we haven't found any issue over there. But very intermittent issue is happening very frequently. So, is there any like timeout parameter is there, or some configuration we can do to improve such things?
Yeah, I'll take that one. So, Gayatri, this is basically a default access token timeout, which is for 1 hour.
Okay.
And you can increase this token timeout to 8 hours or 12 hours as per your need. So there are steps that you need to follow to, get this access token timeout increased. Probably you can find this out with our articles, or I'll just paste the article link in the chat window. Okay.
Yes, please.
Yeah.
Thank you. Yeah.
So just in regards to that, you know how you're saying teams, is that like the equivalent of ITSM support groups?
That's correct. Teams are logical groups of users.
Okay. And for that support group, did I just need to be a member of that group?
Correct.
Okay, because I think we're aiming at doing it individually. Hence why we wanted to raise a request, like to add users to, that kind of stuff. Okay, let me think. So if we create a support group, okay, yeah, that's not going to work. Because because the way that we're going to set it up is we have two environments, a QA system and a production system. Production is going to be shut down, and our QA would be where they edit, create reports. And that's only one that they have editor rights on. So I'm just thinking I can't have a request sitting on prod to do any updates onto QA for the user's use case. That's probably why we went the individual route.
Okay.
Okay.